The topic for today is energy profile diagram and spontaneity of a reaction. Activation energy is the minimum amount of energy that must be overcome for a reaction to take place. In energy profile diagram for exothermic reaction, we can see here that the energy of the reactant is greater than the energy of the product. Hence, heat is released to the surrounding and the heat of reaction is negative. The energy profile diagram for endothermic reaction, we can also see that the heat content of the reactants is smaller than the heat content of the product. Hence, heat is absorbed from the surrounding. For energy profile diagram, endothermic reaction, we can see that the energy content of the reactant is smaller than the energy content of the product. Hence, heat is absorbed from the surrounding. Spontaneity. The factors that determine whether a reaction will be spontaneous or not are enthalpy, entropy, and free energy. Entropy is a measure of the degree of disorder or randomness of a substance or a system. Entropy is represented by S. Delta S is change in entropy. Increase in temperature increases the entropy of a substance. For a perfectly ordered system at absolute zero, minus 273 degrees Celsius or 0 Kelvin, entropy is zero. That is, no randomness in such a system. Second law of thermodynamics states that a spontaneous process occurs only if there is an increase in the entropy of the system and its surroundings. Delta S is equal to delta H over T. If heat is released, delta H is negative and there is decrease in entropy. If heat is taken in, delta S is positive and there is increase in entropy. Water at solid state going to water at liquid state going to gaseous state. From solid state to liquid state, delta S is positive, while from liquid state to solid state, delta S is negative. From liquid state to gaseous state, delta S is positive, but from gaseous state to liquid state, delta S is negative. Change of state from solid to liquid leads to disorderliness. Hence, delta S is positive and vice versa. Free energy. The free energy of a chemical process is the energy that is available to do work. It is represented by change in delta G. Delta G is equal to delta H minus T delta S. For a reaction to be spontaneous, delta S must be positive. Delta G must be negative, that is less than 0. For a reaction at equilibrium, delta G equals to 0. Exercise 1. An increase in entropy can best be illustrated by A. Mixing of gases, B. Freezing of water, C. The condensation of vapor, and D. Solidifying candle wax. The correct answer is A. Mixing of gases. The answer cannot be B because freezing of water is decrease in entropy. The answer cannot be C because the condensation of vapor is decrease in entropy, and the answer cannot be D because solidifying candle wax is a decrease in entropy. Exercise 2. C plus H2O to give H2 plus CO. Delta G for the reaction above at 1300 Kelvin is minus 43 kilojoule. At this temperature, the reaction is A. Not visible, B. At equilibrium, C. Visible, and D, exothermic. The correct answer is option C, visible. Exercise 3. Which of the following equations shows that a reaction is in equilibrium? A. Delta G is less than 0. B. Delta G is equals to delta H minus T delta S. C. Delta G is greater than 0. And D. Delta G is equals to 0. The correct answer is option D. Delta G is equals to 0.